My name is Andre. I'm here to present my final project for CS6963 NYU Poly. Just a quick introduction. FRSED, First Response Suspicious Executable Detector, is just a series of two tools used to try and extract suspicious binaries out of a Windows image, and then use different analysis tools and online reputation systems to figure out which ones a first responder should work on. This is especially useful for environments where you need to quickly identify if a system is infected or not, so you can focus on which binaries you need to analyze as soon as possible. The two main components, one is an Autopsy plugin that's used to be able to extract the binaries from the image. I found that Autopsy made the most sense because it has the entire environment set up for extracting from all different types of images, whereas the TSK bindings for Python were just very difficult for a user to install, so I went with a Autopsy plugin for that portion. And then I use a series of Python scripts to perform lookups and analysis of the executables. So some of them will perform analysis based on the PE binary itself. Others will just perform analysis based on the MD5 by submitting it to online reputation systems. And then finally, the output will just be a JSON file, and there's a nice HTML file that goes along with it that will display it to an analyst so that it's really easy to parse and identify which ones are most important. I wanted to also support a feature that allowed you to perform the analysis offline, so you can have your forensics image can be in an offline environment, either because of corporate policy requires it or whatever, and then perform the extraction on the image, and then take that data over to an internet-facing computer so that you can perform the online reputation lookup. Or if you don't even want the online reputation lookup at all, this entire system can be executed on an offline environment. You just won't have the advantage of having the reputation system report for you. First, I'll demonstrate the use of the Autopsy plugin. There's honestly not too much to it. Most of it's just self-driven, so all you have to do is fire up Autopsy. You're going to select your data source. So in this case, I'm using the data source from our original first module from the class, which is a whole Windows environment with some extra tools that a hacker might use on it. The progress bar will be tracking the extraction, so every binary, every executable, is being extracted from the system. That's going to allow an analyst to be able to submit them to, maybe a sandbox such as Cuckoo or VirusTotal, whatever makes sense for their environment. So you can see all the binaries being extracted right there. These are going to be stored in a subfolder of the case that you're going to have for Autopsy. So you can see in there's a binary case, and then right now we're just waiting for the extraction to finish. The extraction actually doesn't take too long. It's just ripping out the binaries right out of the image, so it's actually quite quick. And it's doing that based on PE signatures as well as extensions. So if something says it's an executable by extension, we grab it. If it says it's a PE by having the MZ header, we grab that as well. And then once that's done, the JSON, which is pretty much just a massive dump of all the information, is output to a file and then used in the next Python script. The next tool is the Python script that performs the analysis as well as perform the reputation lookup. Again, there's not much to this. It's pretty much self-driven. There are a couple command line switches, so if you want to disable team summary lookup or disable PEID, which can take a little bit of time, those are available to you. But generally I just suggest running it with the defaults. And you only have to run it against the output directory, and then it'll find the JSON file and all the executables underneath it. During this lookup phase, it's going through each binary, figuring out what its PE signature looks like using PEID, as well as submitting the MD5 only to Team Summary to see if they have any intelligence on this binary in the past. Team Summary was chosen just because they have a very easily queryable system. I also tried integrating with VirusTotal, which I have started a relationship with them, but it's going to be quite a bit slower and requires a custom API for each user, so that might be a little bit difficult for users to implement. Other systems like Bit9, whitelisting services do not have any kind of public API, so it's kind of difficult to find a bunch of reputation systems that are willing to just give you data. Team Summary is one of those ones that's very community driven, and they're happy to do it. So I was pretty excited to use them as a reputation system. As I mentioned, this process can take a little bit of time, so we're going to fast forward 15 minutes so that we can just go right to the analysis portion of things. As you can see here, execution was finished successfully, so now we're going to take the JSON file that was output from this system and put it right into a web server that's going to be referenced by HTML file. This HTML file is going to show it in an easily displayable fashion for us. I'm just using a local web server, XAMPP, for Windows, but it wouldn't be very hard to implement this on a server so that any report is automatically displayed to a user. So maybe you could have a case that would just automatically display it to users. But for our purposes, it's just kind of a proof of concept, so it's just going to be locally served up. And there's our view. GUI is very basic. I'm just using a basic grid system and then taking a lot of the metadata that I can extract from the image and the files and displaying it to the user in an easily viewable and sortable manner. Here's a view of the GUI a little bit closer up. So you can click through all the different binaries. You can use the keyboards to move up and down. And since there are going to be collisions with MD5s, maybe the location is, one or two different instances. It'll show you on the top what the binary is, and then on the bottom show you all instances of that binary as they are on the image. All the columns are sortable, and then you can also view all the different sections. You can sort any of the different columns. So if you want to look at the highest AV coverage or the PID signatures that match, you can sort all by that too. So sorting by AV coverage from Team Cumry is a quick way to find some bad stuff. Now this is going to be publicly known malware, so things that AV systems are detecting. But when you do select one, you're going to be able to show it in the bottom pane. It's going to show you exactly where that is on the system, also some of the dates that are associated with that, so when it got written to disk, when maybe it was last used, that sort of information, which is going to be quite useful for an investigation. PID is going to be very helpful as well. It's going to show you maybe some of the binaries that are packed. So if a binary is not known by AV but is packed, that might show you something that could be malicious, something that's definitely suspicious. And there are going to be some false positives here. PID does have some. So some Microsoft binaries might be flagged as Armadillo when they actually are not using Armadillo Packer. But nonetheless, it's still good to check them out as a first pass. Here's an instance of a binary that might be kind of useful in case an investigation yielded that a user was using anonymous software. That would show you that, yes, this person was actually using an anonymizer, which might be useful for the purpose of the case. Many times you're going to want to take the binary and run it through your own personal analysis system, whether that's Cuckoo Sandbox or if you want to submit it straight to VirusTotal yourself, whatever you'd like to do. That's why we've extracted all the binaries to disk. So if you do find something that's interesting on here, like maybe that MD5, all the files are sorted or named by MD5, so you can easily just go grab it, submit it to VirusTotal, or submit it to your offline analysis system, open it up in IDA, whatever you want to do. It's right there already ready to go for you. That concludes my presentation. I hope you enjoy the tool. I hope it actually becomes useful for some people out there. I'm considering updating it with some more information and some more functionality, such as VirusTotal integration or submission as CW Sandbox or to Cuckoo or something like that too. So I'm probably going to roll it over to GitHub maybe in the next week or so, and then perform some updates and hopefully get some forks out of it too. So please let me know if you have any questions, or we'll just discuss on the Blackboard system. Take care.